there's a 1.1 version just being published here, presumably by Stefan. I can't write, bang. You know, you've got to refresh before you can go again. So, and let's see if we have another. Okay, and here we get somewhat more interesting thing. Here's our setting up the foreign keys, and again, you're just representing. So this is a fairly typical way of doing it. You get your field names into your int bars, and then you just set up a foreign key. And it's all very, very straightforward. I mean, relational algebra is not difficult. Representing it in Smalltalk is not difficult. So this stuff is straightforward to do. And of course, for performance, indexes. While you're functionally developing, you probably won't care about this, but once you start caring about performance, sorry, remember I can't select things here. Yeah. So, indexes matter toward the end, and you want to use the protocol to set them. Bit more to be aware of. Okay, now a chance to describe some slightly subtler stuff. You create a foreign key. Does the database have to know about it? Well, not necessarily. You may know perfectly well that this legacy schema has values in 2 columns that really have to be the same value. The person who implemented the legacy schema never did it. It's still running in various ways, so you can't get at it. But you don't want your application to be writing rubbish data. So you just you effectively, not exactly lie to Glorp, but you basically pretend to Glorp that the database schema was designed better than it was. Create a foreign key, but don't create it in the database. And that's quite a natural thing to do. Imaginary tables. Why would you want an imaginary table? Well, first of all, because you want an embedded one-to-one mapping. So, okay, at this point, let's see if we can actually do something vaguely reminiscent of a demo. Okay, so why would you want to grab fields from multiple tables? Okay, well, let's look at the Glorp bank account again. Okay, bank account. The bank code, the branch code, and the account number. But now let's look at our domain objects. Okay, we have Glorp bank account and Glorp bank account number here. You are choosing to regard the bank account as simply an overall object that aggregates the customers, on the one hand, multiple who have that bank account, and the branch that holds that bank account. You have a separate object called bank account number, which encapsulates all the data of an account number with its bank code, its sort code, its branch location, and so on. But that's not the way it is represented down in Glorp. That's actually, as far as down in the database. As far as the database is concerned, you have one table. So in other words, you're wanting to turn one table into 2 objects, and that is where an embedded mapping comes in. So we can actually look at okay, so here's our descriptor for bank account. It knows its table. It knows that it's got the id mapping. It's going to map to the account holders. That's fine. We have a simple account holders. And it's going to map embedded value one-to-one mapping to account number. And if we now look at the descriptor for Glorp bank account number, it is using the same table. Now, this is all you have to say. Glorp is reasonably clever. You tell it you're using an embedded mapping, and it can work out all the rest of the stuff. So now you've basically mapped 2 objects up in your domain model onto one table, and it's got a simple hierarchic relationship. Actually, I want to go on for a bit, and then I'll come back to that. So if we can park that for a moment. Okay. Another case is you might want to map to more than one row. Trivially is if you're wanting to group the rows or make the rows say I only want distinct rows. But more generally, you might want specific field for multiple tables. So let's take an example of why you might want to do that. Let's take frequent flyers and airline situation. Yeah, absolutely.
Thanks.
Suzanne's a frequent flyer, so she will have an entry in the frequent flyer table as well as an entry in the ordinary passenger table. I am not. I have no entry in the frequent flyer table. If you want to, sorry, I beg your pardon. I'm describing a different case. Sorry, let me go back to the case that I was intending to describe, which was a video descriptor. This is imaginary tables. I beg your pardon. I was about to talk about how to join. Right, later. Okay, reset. Why would you have an imaginary table? Why would you pretend to Glorp that you have a table when in fact the data for that table is in 2 or more rows? Suppose you have a video store that sells in-store and sells to customers, and it does not have a customer table. It simply has records for the customers in the various sales that it makes. You might decide that you want that actual customer table, and this is an example of setting up such a thing. So here's our table for video rental. It's got its standard id, it's got its standard store ID, it's got its foreign key between the store table and the customer table. Now we're going to get, there's a customer name, there's a customer date. We're going to have a customer table, which we're going to call video customer, and we're going to set up foreign keys from these video rentals to that. And then, of course, we give it its own data. Now, we do that here. We do much the same thing here for the purchase of videos, because there is no table. If you were designing the schema from scratch, you'd have had a customer table and done the joins. But in fact, this data is stretched all over the place. So at the relational level, you can naturally map that and have a table for video customer, and you just say, this is imaginary. There is no actual table for that. I faked up a table by doing joins from other tables. And I know that that will make my life easier. Perhaps there's another system where there is a customer table. The schema was better designed, or it was evolved, and you want your descriptor system to be able to work more happily with both. So you don't want to have the complicated mapping up to the domain class level. You just want to have the mapping at the table level. So that is another area where you get imaginary tables.
So you can use that table?
Yes,
Also
you can
joining?
Yes, it will join. Everything will work. You can, at the top of Glorp, you can set it up in your mappings. That table is there as far as Glorp is concerned, and then at the bottom level, it will map it all correctly. And then later on, you can evolve your schema to actually have that table, and you've got very little to change. You just say, is imaginary false? And now you've done your update. So it's a way of pretending to Glorp that something you're going to do hasn't, even though it hasn't happened yet. Okay, and a point finally to be aware, this bottom line, so again, this stuff above, you know, all aware, this stuff below, occasionally aware, we are at the bottom level. Glorp is about this wonderful system that says, I'll hide everything to you. But when you're setting up the mappings, this, you have to be aware that at the bottom layer, things are not hidden. In table definitions, you are indeed doing stuff. So if you set a default value for a field, you may want to use this slightly clunky, you know, you use this slightly clunky way of getting at it, because you haven't, that's enabling you to forget about it on all other occasions. So You might want to just say, value true or false, but there are databases that map that to 1 or 0. So you actually say, just a moment, I've got to go to my field, and I've got to say, give me the converter, and then set the default value using this kind of stuff. So the converter will convert the false to the database representation. You never have to do that normally up at the top once you've got your mappings ready. Ugly gloved stuff, but if you're writing the schema, you may occasionally need to do that because you've got one of those values and you care about being on enough platforms. You actually are dealing with a platform that doesn't always give you the same meaning at all. Okay, so let's now try and pull it all together. And I'm sure I've been somewhat unclear in this stuff, but let's actually get on to descriptors and through it. So, okay, here's a nice simple descriptor. I have a bookstore customer who buys books. This is a typical format. There's a descriptor per class. There's not necessarily one table. There could be loads of tables for descriptor, but you're going to have to get the one or more tables. Usually one table, the first table is assumed to be special, and so you set that into the descriptor and then you can just add them. You may have some very simple mappings, and you may have some slightly more complex mappings, and you notice here you said very little. I have a mapping to books on order. All I'm going to tell you is that the reference class for this mapping is Glorp book. You go and figure out all the rest. And often, Glorp can actually do that. You can define the mappings very simply because Glorp's quite clever. We'll be looking at cases where you have to tell it a lot more. But very often, you just say, all right, I want a many-many mapping. I know that in the database, that means there's a link table, there are joins, there are foreign keys. But up here, I'm just telling you, I know in my domain class that a bookstore customer orders books. And that's all you have to tell it. Often, of course, it is more complex. Okay, so descriptors are a high-level thing that pull together the tables, the names of the map fields, what the mappings are, and then you get into occasional stuff. Multi-table join is an example of what you might call occasional stuff. Now we can talk about, okay, sorry, I started in on that and then suddenly realized, hang on a sec, I've jumped too far ahead in my talk. Now we can talk about frequent flyers. Okay, so Suzanne, frequent flyer, has an entry in the frequent flyer table and an entry in the passenger table. Me, not frequent flyer. Entry in the passenger table, no entry in the frequent flyer table. You want to set up a mapping that says, show me data, including the frequent flyer. If you used an inner join, Suzanne's a person and I'm an unperson because I have no entry in the frequent flyer table, so I join to nothing, so I'm not there. So you have to use an outer join that says people who have no frequent flyer status do join to null. And this is what inner and outer join is, and if you know SQL, you're familiar with this kind of thing. So this is one of the various subtleties which Alan has attacked so that mostly you don't have to, but you may find yourself thinking, what if I call my join an outer join? What is this multiple join stuff going on? So that's an example of a domain case where you choose to use an outer join. 9 times out of 10, you just take join, you take the default, which is inner join, and it works. Very occasionally, you find yourself constructing something and you're saying, I want everyone to appear here. That's just how the thing works. So Glorp can work out that you ignore. If you tell Glorp that you've got an outer join, it can work out to ignore the outer join in many cases. I don't have frequent flyer knowledge, so don't waste your time trying to go to the database, find the null, and then join the null. Just write it or read it without all that sort of stuff. But there is this multiple table join, and it's there in the descriptor so that you can tell it if you have outer joins. And a point to be aware of is, hang on a sec, I've told it in the join. If I set up my mapping to have a join that was an outer join, I've already told it. Why am I telling it twice? And my answer actually is probably you shouldn't. Probably we should compute this. I think this is something that Alan did a long time ago. It's still in there. It gives you an optimization for reading and writing, and you need it for deleting. If you forget to put it in, it's not there. So the point is, if you've written outer joins, you also want to set multiple table join. I'm hoping in the next cycle you will no longer have to worry about this. But that's one of the kind of slight warning things. I'm not going to talk about cache policies now, except to note that you can, if you want, have the descriptor having a different cache policy from the other. So let's get into all its complexity and try to look at this. Okay, so we can all understand trivial. One class, one table, one instance equals one row. Not too hard. Inheritance. How would we do inheritance in Glorp? Let's look at some code. Okay, some of you may recognize this from my 2011 talk, where I talked about having a legacy system and then a web app, but the web app needed to view the data in a different way. So you ended up with two systems, the genetics descriptor system, which was the old legacy, and the referral descriptor system, which was a new one. And in particular, it had a different way of handling the inheritance of consultants. Let's look at the domain, so we know what the domain is. Here's your consultants, and we have diagnosing consultants and referring consultants. Okay, so you could dump all them in one table with all the fields for both. Sparse table, some rows have no entries, nulls for all the referring consultant stuff because they are a diagnosing consultant. Some rows have nulls for all the diagnosing consultant stuff because they're a referring consultant. Or, of course, you could have two separate tables, diagnosing consultant, referring consultant. What's the impact of those two? Well, first of all, here we have my superclass. You will need a type resolver. If you are going to handle inheritance, you will need a type resolver for, and again, it's a usual system, embedded class name. Consultants is my root class. I'm going to do some type resolution. What am I doing in the referral system? I'm doing horizontal. Horizontal, table here, table here, table here. They make a nice row. So horizontal. Diagnosing consultant, referring consultant. What did the legacy system do? It used what's called a filter type resolver, which is so-called because it's one table and you filter out the fields. Okay, so how do I actually do that? Well, here's my descriptor for referring consultants. Okay, get my type resolver for consultants, register me. The key value I'm looking for is referring. If you see this value, I want you to build a referring consultant object, not a diagnosing consultant object. The key field is role. You are looking in the table for the column role. Whereas the descriptor for the diagnosing consultant, of course, looks exactly the same, except the key is diagnosing. And of course, they're looking at the same field. They wouldn't necessarily have to, but they are looking at the same field. And what does the descriptor for consultants say? Okay, so that doesn't have to say anything, because, but let's look at the referral one. Sorry, let's go back there. Okay, so that's your two. You've got a horizontal field, and everyone's a diagnosing consultant or a referring consultant. Okay, so the other system. Here we have type resolver is horizontal. So you said, here's my type resolver for consultants, just register. There is no field to discriminate on. You simply say, register me. I'm telling you that I'm a concrete subclass of this type resolution. Here we have a descriptor for referring consultants. Again, I'm telling you I'm a concrete subclass. And here we have, where was it? I was looking at it for just a minute ago. Where am I? Oh, right, okay, so, and in the superclass, you have the common statement, I am registered, I am abstract. And this is telling the system there are no consultants who are not either diagnosing or referring. You could have it non-abstract. Your root class could also have table. Your root class could also have data. but in this case, you're just saying. So that's a simple example of the system where you're just saying. Okay, so what's the consequence of that for the far side? Well, let's look at someone who's trying to join to it. Here is the RA site that's wanting to join to consultants. Okay, I am using a polymorphic join. Okay, so that's basically saying, regardless of how I did my inheritance, I want you to know that in my domain model, I have a field that holds a consultant. Might be a diagnosing consultant, might be a referring consultant, whatever. And this is how you express it. You just say, I've got a polymorphic join to the field from my field. So, and that's expressing the join, and it just handles for you all that complexity of, do I have one sparse table, do I have several tables, do I change my mind, etc., etc. You can just set it up like that. So that's one example of how you get into slightly more complicated things. General, I already talked a little about imaginary tables. Let's see if we can get into imaginary tables again, and let's see if we can actually run something. For example, okay, let's actually put a breakpoint in here and see something. I think this is probably a good place to break it. Hoping to avoid the O'Keefe experience. But let's just run a test. Okay, so we are a unit of work, which is Glorp's understanding of a transaction. We have a row map. Let's look at our row map. Okay, so do you remember, I mean, it's ridiculous even to, I mean, it's an insult to ask you, do you remember all that stuff I talked about, video store and online purchases? I mean, obviously, but if I've been sitting there, right, I'm thinking, what? Okay, so let's try and make it. Okay, so here's my imaginary table. As far as Glorp concerned, my imaginary table was real. So I had customers, and I had data. I had my instance model. I'm now trying to write it, and it's all been mapped down. So here I have my database row, which knows that I'm the video customer table, and I've got, various data, and so forth. Here's my purchase. So various people have done purchases and so on. Here's my rentals, and this is basically, I mean, we could actually go and look at the actual objects, but if you'll trust me, you can probably see, I think, that there are instances of video customer, the domain class, which had instbars with values Bob, 16th December, and so on and so forth. They've been mapped down here. They're now going to be mapped to purchase links. So when I write this, none of these rows will actually get written because the table doesn't exist. Instead, it's all joins of the information in the store table, in the rental table. So you see the rental table also knows about the customer name and the customer birth date and so on, just as the customer itself. Here's Bob with his birth date, and did Bob rent anything? Well, no, Eleanor rented here. Yeah, here's Bob, he rented something. And so of course that's the only place the data really exists. Bob and 16th December and September and all that stuff doesn't exist in the customer table because the customer table is imaginary. It's not there, but it exists there. And Glorp has mapped it. It created the rows for the video customer to make its life easier. And if the table was real, they'd be written, but in fact, they are all joined into the other rows. And so this is how you've actually mapped your domain model into a set of rows that are now ready to be pushed out into the database. Now, if people are kind of, if I made sense there, then I'll throw this away and carry on. And if people are thinking, what's he talking about, then here's your chance, if you aren't in despair, to make me say more. I'm guessing. Okay, right. So that was actually seeing us do something. So I'm going to throw that away, carefully not write it. I'm going to carefully remove it. Actually, I'll leave my breakpoint in. Okay, so that was imaginary tables, and if we'd done the embedded table, you'd have seen exactly the same. You'd have seen a Glorp bank account object and a Glorp bank account number object being written to a single row of the table. Okay, the other one is dictionary mapping. Now, obviously, I said you can say, collection bag of, string or of domain class, you can say collection dictionary. You know, we use dictionaries in our domain models. We quite naturally have int bars that contain dictionaries. It's an obvious way of avoiding creating a class. You just group it all together. But of course, when you write at the table, that means you need two mappings, not one. You've got to map the value, just as you would with a set or an ordered collection, but you've also got to map the key. And that's just to understand what's going on in dictionary mappings. You just be aware you've got the key value as well. And if you do that, you can have Glorp recover dictionaries for you and take objects that have dictionaries and just write them to tables very straightforwardly. And it can be trivially, you know, I have a key column and a value column, or it can be vastly more complicated. My key column is, you know, several things or something like that. You also have conditional mappings, and you have conditional collection mappings. A common case you'll find is that you actually have a constant mapping as the else. So it's basically the conditional is often this might be here or it's not here. If it's not here, you have something like, you know, absent or some other, you know, constant value. So often you set up a conditional mapping. And again, its protocol is fairly straightforward, and you have examples there. I am not going to talk about ad hoc mapping now, and part of me is hoping that 90 minutes will have elapsed before I talk about ad hoc mapping. You know, I told you earlier that the great thing about Glorp was it never abandons you in the jungle. You're always there. Well, ad hoc mapping doesn't abandon you in the jungle, but if I started to talk about it, you'd start to think that it was. It's complicated. When you need ad hoc mapping, please contact SYNCOM support and we will be delighted to help you. And I'm going to write stuff about it, but trust me, how long have we actually got remaining? 7 minutes. Okay, so I'm not going to do that. Okay, right. Okay, so that was table level. How do you think of your tables versus your classes? Now we're getting into field level mapping. So obviously, direct mappings are between simple types, things that can live in a column. Number, string, boolean, timestamp. To one mapping, same thing, but it's complex. You know, author and book, or something like that. And to many mappings, the main thing just to remember there is what's the collection type? Set, bag, dictionary, whatever. Pseudo variables. You may want to define something which you don't have an instvar for. And you do this because when you go to the database will know this information. You don't want to bring it back. It's pointless to bring it back, but you can write a much better query. The example I give here is of the actual metadata, database fields itself. Suppose you have a database field, metadata type, and you want to look at its primary key constraints. The database field doesn't naturally contain that. The database field class participates in primary key constraints, so it's not natural to have a database field having an instvar primary key constraints. You don't want that in your domain model. But you know very well that when you're writing read database field where each, you might want to say something like each primary key constraints includes, you know, some other field or something like that. And you know that when that query goes over to the database can quickly find that information and get it for you, which is much easier than you bringing back a lot of information to your image and then trying to sort it out in the image. So that's one reason why you would use a pseudo variable. I will define something that I don't want to cache, I don't want to map. So this is kind of the opposite, if you like, to an imaginary key, imaginary field. There you were saying, I'm going to know about it in Glorp, but I'm not going to have it in the database. Here you're saying it's in the database, and I'm going to use it in my queries. But, you know, don't bring the data back. Just get me the final answer and bring that back. The other time you'd use it is simply as an alias. So for example, if primary key is too long for you, you define a pseudo variable called id, which you map to primary key. And that's a trivial use, but sometimes good. Proxies. Let's see a proxy. Proxy on nil in actual fact. However, it's still adequate. Let's see if I can find. this is still making the point. I'm not finding interesting objects, but the fact is, Glorp is trying to save you time. So normally, by default, the various things it's related to, it brings back proxy objects on them. And that is one example of what a proxy looks like. It can have a special action that will be fired when you try to instantiate it. It has a query that says, I know how to get this object out of store, and it has a value which has now been instantiated, but previously would have been uninstantiated. Let's go and look at an uninstantiated one. There we are, okay. This is telling you, I know this is going to be a collection of store blessings, but I have not yet gone to the database and got them. Now obviously, performance is immensely affected by when you go to the database and when you don't. Often you set this in your queries, but you can set it by default on the mapping side. Now, at this point, I'm thinking, given what I have left, you guys have been sitting here, and all you've seen is how to set up the mapping. I literally have not got to how to do the queries. So I want to go on and do the queries. So I'm going to speed up a little in terms of doing things. The join is a utility class. It's very important. In a sense, you don't need it, but actually you need it desperately. It is so much easier to say join from this column to that column, from to, than to write a block expression for the join, because the block expression I show first, which is perhaps relating to the join I show, isn't the one you write. What you actually write is the join from the far end. And there are reasons why you do that, which you can get me afterwards, but just trust me, I know from experience, it's much easier to write join. So this is a wonderful utility class. It deduces everything it can. I showed you an example of reference class. You can simply give a reference class and not give a join at all. It'll work it out. You can give an explicit join. You can tell it, I know there's a link table. Use the link table. Find the link table. You can work it out for me. You can actually say, here is a link table join. I'm going to tell you how you join to the link table. Or you can say, here is a target table join. Or you can actually tell it the relevant link table to field. So there's more and more and more. Okay, so you build up the joins, and here's the outer join stuff that I was talking about before in terms of the frequent flyer stuff. Okay, now we're getting on to stuff that's common. Okay, so that was all about mapping. Everything you've heard so far was just about setting up your Glorp mapping. Now we're getting on to stuff that's a bit relevant to how mappings and queries worked. You've got a thing called the message archiver. It eats the block. I was going to do a long demo. I'm not going to do a long demo. Trust me. How do you actually do? Let's go back and look at this. Okay, so here you've actually got where each, and this is all Smalltalk. How does a Smalltalk get into code? The message archiver eats the block. It has to evolve inline selector, so if you've ever wondered why you write capital AND or AND instead of lowercase and, you don't use AND, you don't use OR, you don't use if true or false, you use these alternatives for it. But apart from that, the message archiver eats the whole thing and transforms it into something that can be mapped to SQL. And in that block, the functions are mapped in the following order. So the first thing is function. Descending is a function. That's going to turn into a piece of SQL code that will affect the descending. And that's defined as a function. Let me just see if I can find this. It is defined as a function in the thing that initialize functions. Calls. Okay, so I'm definitely going to show that. Anyway. Okay, right. Okay, right. There is a lot more in Glorp. I'm really sorry. I have not estimated my time correctly. these with detailed notes will be put on, and hopefully the detailed notes will be easier to understand. I would love to sit with any of you at any time in the remainder of the conference and go through specific stuff. And there is lots more to talk about. I'm truly sorry. My timekeeping estimates were not good. So I guess it's questions. I'll just give you a quick flavor. Okay, so Michelle.
How would you compare Glorp with Java equivalents?
My experience, which I must stress now is a few years out of date, is that it's a good deal better, particularly in the cases where you have this mix of legacy, constraint, and new requirement, where you're having a complicated adaptation to do. So, I mean, yeah, I mean, I wouldn't dream of using any of the Java stuff I've seen. It could be I'm not up to date on that, but that's where I come from.
You showed us an example where you used, well, I'm used to using self-session read class,
Yeah.
where,
Yeah.
and this one doesn't allow subselects and stuff, and you can only really use SQL functions within that block. But we've seen a block here where you do query, read,
Yeah.
column, where, column, and there is a new statement, query new, and you even use
Yeah,
temporary
okay, yeah,
variable there.
Here's the example I was going to give. This is a clone query where you notice I define two queries inside it, and then I'm sending them to not in and exists and so on. The great thing is you can use symbols, you can use blocks, and you can use queries as the parameters of your things. And there are examples here, and by all means, let's sit later. You can.
Yeah, that's interesting.
Yeah,
That's extremely
and that's obviously that relates to the fact this first line and thing, do as much on the server as possible. If you want performance, there are things that SQL can do which you don't want to go to the server 10 times for bits of stuff that you then process in VisualWorks. You want to write one really complex query, send it to the server, and just get the data you want back. And one of the ways to do that, so there are ways to do that. You can do that in Smalltalk, this query unional query that I'm showing up there, but you can also just write really complex queries where you treat the subquery as a parameter. X not in my subquery exists my subquery.
Yeah, that's exactly. I have a lot of examples for.
I have some examples of those in the store talk that will be this afternoon.
Oh, okay, good.
Yeah, go ahead.
Could you have cursors?
Yes, I have an actual reference to cursors, if I can only remember where it is. I may have gone past it. Yeah, here we are, bottom of the slide. Okay, for most databases, not in Postgres at the moment, you simply choose Glorp cursor stream, you put it in, and then you get, and obviously for a web app where you don't want the user to wait while 1,000 rows are retrieved, but you'd like to show a few of them, that's just what you want. So you use it. Anyway, thank you for your patience. I do apologise for the fact that somehow in my room this seemed to go a lot faster. And I would love to talk to anyone who wants to see particular bits or to show me examples of how do I code this. You know, I'm at the social event and I'm here till Friday after lunch. So.
Can we get access to the
Slides? Oh yes,
slides?
yes. I will finish them up before. If you want to copy right now because you want to talk to me, I can certainly talk about that. These slides and my notes. So there are a lot of notes underneath that. After a final check through before the end of this conference, they will be available.
Yes, it would be nice to have the slides as soon as possible. So
Yeah,
maybe
okay.
we can.
I'm happy to give you, provided you know I'm probably going to spell check the
You
notes
can
and stuff like
read
that.
them and then ask you
Yeah.
questions
Yeah,
for
yeah,
a specific.
Sure. There's a version number on them. So
Yes.
yeah, absolutely. Bring me your stick.